So now that we've walked through the implementation, let's step back and take a look at other considerations that are related to applying the builder pattern in practice. So there's a number of positive benefits that come from applying this pattern. One of the most obvious ones, which you probably already got a feel for as we walked through the implementation, was the ability to isolate the code for construction and representation. These two things are decoupled. The construction part is really managed through the build methods. So that's the part that we know is going to do some building. But what actually gets created there is up to the implementation of build. So we're kind of decoupling the notion or the structure of how build occurs from what is actually being built. So here's a very simple example that we've already looked at before, where we've got number expr and add expr with their build hook methods. And you can see that we can get very fine-grained control over the construction process because each composite node controls how it's constructed. So the parse tree in this case has a build method, and then that uses the corresponding composite node hierarchy to figure out what to actually create. And so that's very localized, it's very clean, it's very clear what's happening at every step along the way. You could also change your mind and modify how things work. So you could move from a situation where you're using composite add node, for example, to some other representation like a tree node. And as long as it conforms to the build interface and as long as it has the right component node pointer returned, you can change the representational details without breaking anything else. You can keep all the other parts of your program and just change how the representation is being applied in the implementation of the code. So that's another cool example. It's a great example of having extra levels of indirection, which are always useful in software to buy yourself time to figure out how to modify things to meet your requirements more effectively down the road. Of course, it's not all rainbow and unicorns. So there's also the issue that you have a lot of classes. This is almost always the case with these patterns that involve groups of things. Composite is a good example of this. Visitor is a good example of this. Builder is a good example of this, where you've got many things that are being created out of piece parts. Abstract factory, another kind of example of this. And if you don't understand the patterns, then you're going to be drowning in a sea of classes and objects, which of course is not a desirable thing at all. But once you know the patterns, it helps to reduce the surface area that you need to understand what these classes do. So rather than looking at dozens of classes in isolation, it's actually much more effective to think about those classes as playing roles in the patterns that we've come to learn through the material we're covering here. So once you know that, this stuff is playing the role of the builder, this stuff is playing the role of the composite, this stuff is playing the role of the bridge, etc., it becomes a lot more tractable intellectually to keep your mind around what's being done and how the various pieces fit together. From an implementations point of view, you can think of the builder pattern, which is a creational pattern, is basically a factory with a mission. So unlike the regular factory method pattern, which usually creates one object, the builder is actually creating a family of objects that have to work together to make some more complex composite object. And so you can basically think about it as taking factory methods and then ensuring they're being called in the right order to do the right thing at the right time. As we see here, going from a parse tree representation to an expression tree representation. So builder is just more directed, and that's of course why it has a director as part of its one of the roles in the pattern. There's lots of known uses that are described in the Gang of Four book. There's examples of ET++ had an RTF converter, Smalltalk 80 compiler used the builder pattern to make various elements in the compilation process. Of course, my very favorite example of the builder pattern, which appears in the Gang of Four book, is the ACE service configurator framework. This was actually some software that I developed way, way back in 1993. Hard to believe how long ago that was, when I was working on my PhD. And what the service configurator framework does is it reads a script and then goes ahead and dynamically links in DLLs or shared objects or shared libraries, and then has factory methods in those DLLs or shared libraries that manufacture various components that are all stitched together to basically dynamically configure the behavior in an application or in a service. Nowadays, we would probably refer to this as something along the lines of either the component configurator pattern or dependency injection, those kinds of things. But I had come up with this back in the early 90s when I was working on my PhD. And I was also at the same time reviewing the Gang of Four book before it was published. And as I was reading the builder pattern, I suddenly realized that what it was describing was exactly what I had come up with to implement my service configurator framework and the way it parsed the elements that it looked at. And that was really cool because I suddenly really dawned on me that these patterns were things that good developers would stumble upon on their own, but perhaps not appreciate the generality and multi-use applicability of what they'd done. And the Gang of Four gave them names to the patterns. They gave them structure and participants and applicability and intents. And so this really helped convince me that these patterns were more than just a passing fancy, but they were something inherent in the way that good software designers and programmers build their software systems. So that's a good example of the builder pattern in practice, which was something I had done a long, long time ago. There's another form of the builder pattern that you might be familiar with if you've programmed a lot with modern Java frameworks. And this is what's sometimes called the effective Java style of the builder pattern. And it's named that because it was popularized by Josh Block in his book, Effective Java. And basically what you do here is you have some kind of class, which I've given the rather unimaginative name builder to. And you can see that what we do is we have the builder class, which defines a whole bunch of setter and getter methods. Of particular interest here are the setter methods, like set summary, set description, and so on and so forth. And what you can do is you can use the builder pattern to make a builder instance using the default constructor, which doesn't really do much of anything. And then from that point onwards, you can chain together a bunch of setter methods in so-called fluent interface style. And what this does is it allows us to be able to add the various elements we want to build into our object as we see that we have a need for them. So you can dynamically decide what you want to provide. So rather than having a bunch of constructors that are confusing and hard to know the order of things, instead you can just go ahead and add or build in the various elements you want a piece at a time in a more a la carte style. So in this case, we're going to go ahead and give it a description saying builder test, and then set the summary where we say it's cool or whatever. And when we're all done setting all those various fields with the setter methods in a fluent way, then we go ahead and call the final build method. And that, as you can see here, turns around and then makes an actual instance of this object with the various fields provided that were set by the setter methods using the fluent interface pattern. And you might want to take a look at the link on Fluent Interface if you're not familiar with this particular style. But it's a very, very popular way of programming frameworks for many different languages. I'm using Java here, but obviously the concept's generalized to other languages as well, like C#, JavaScript, C++, and so on. So to summarize what we've done here, we have applied the builder pattern to recursively build composite-based expression tree data structures by processing the parse tree that was created by the interpreter. So once again, you can kind of see these patterns don't exist in isolation. They work together in a very convivial way. They like to interact. Patterns are very social. They enjoy dependencies and collaboration and working together. And in fact, this concept of interpreter and builder and composite, along with bridge, by the way, to encapsulate the details of the composite, actually forms something known as a pattern sequence. And we'll talk more about pattern sequences later. Pattern sequences are examples of more sophisticated pattern relationships that go above and beyond patterns in isolation, or even patterns in pairs that are called pattern compounds. We'll cover that later, though. So for right now, if you're interested in looking at more information about pattern sequences, feel free to take a look at the link at the bottom of the slide. Otherwise, stick around and come back in a few days, and we'll have more material to talk about these pattern relationships.